Welcome to Cloud Stories, the podcast about Microsoft Azure. In this module, you'll learn about artificial intelligence, AI terms, and available services in Azure. Artificial intelligence is increasingly prevalent in the software applications we use every day, including digital assistants in our homes and cell phones, automotive technology in the vehicles that take us to work, and smart productivity applications that help us do our jobs when we get there. There are many definitions of what exactly AI means, some technical, some philosophical, but in general terms, we tend to think of AI as software that exhibits one or more human-like capabilities, as shown in the screen. Visual perception. Visual perception is the ability to use computer vision capabilities to accept, interpret, and process input from images, video streams, and live cameras. Text analysis. Text analysis is the ability to use natural language processing, NLP, to not only read, but also extract semantic meaning from text-based data. Speech. Speech is the ability to recognize speech as input and synthesize spoken output. The combination of speech capabilities together with the ability to apply NLP analysis of text enables a form of human-compute interaction that's become known as conversational AI, in which users can interact with AI agents, usually referred to as bots, in much the same way they would with another human. Decision-making. Decision-making, the ability to use past experience and learned correlations to assess situations and take appropriate actions. For example, recognizing anomalies in sensor readings and taking automated action to prevent failure or system damage. There are several related terms that people use when talking about artificial intelligence, so it's useful to have clear definitions for each. Data science. Data science is a discipline that focuses on the processing and analysis of data, applying statistical techniques to uncover and visualize relationships and patterns in the data, and defining experimental models that help explore those patterns. For example, a data scientist might gather samples of data about the population of an endangered species in a geographical area and combine it with data about levels of industrialization and economic demographics in the same area. The data can then be analyzed, using statistical techniques to extrapolate from the samples to understand trends and relationships between human activities and wildlife, and test hypotheses using models that show the likely impact of human activity on the wildlife population. By doing so, the data scientists may help determine optimal policies that balance the need for economic well-being for the human population with the need for conservation of the endangered wildlife. Machine learning. Machine learning is a subset of data science that deals with the training and validation of predictive models. Typically, a data scientist prepares the data and then uses it to train a model based on an algorithm that exploits the relationships between the features in the data to predict values for unknown labels. For example, a data scientist might use the data they have collected to train a model that predicts the annual growth or decline in population of a species based on factors such as the number of nesting sites observed, the area of land designated as protected, the human population in the local area, the daily volume of traffic on local roads, and so on. This predictive model can then be used as a tool to evaluate plans for housing, infrastructure, and industrial development in the local area and assess their likely impact on the local wildlife. Artificial intelligence. Artificial intelligence usually, but not always, builds on machine learning to create software that emulates one or more characteristics of human intelligence. For example, balancing the need for wildlife conservation against economic development requires accurate monitoring of the population of the endangered species being protected. It may not be feasible to rely on human experts who can positively identify the animal in question, or to monitor a large area over a sufficient period of time to get an accurate count. Indeed, the presence of human observers may deter animals and prevent their detection. In this case, a predictive model could be trained to analyze image data taken by motion-activated cameras in remote locations and predict whether a photograph contains a sighting of the animal. The model could then be used in a software application that responds to automated identification of animals to track animal sightings across a large geographical area, identifying areas with dense animal populations that may be candidates for protected status. Increasingly, software solutions include AI features, so software engineers need to know how to integrate AI capabilities into their applications and services. The advances made in machine learning, together with the increased availability of large volumes of data and powerful compute on which to process it and train predictive models, has led to the availability of prepackaged software services that encapsulate AI capabilities. Software engineers can take advantage of these services to create applications and agents that use the underlying AI functionality, using them as building blocks to create intelligent solutions. This means that software engineers can apply their existing skills in programming, testing, working with source control systems, and packaging applications for deployment without having to become data scientists or machine learning experts. However, to fully capitalize on the opportunities of AI, software engineers do require at least a conceptual understanding of core AI and machine learning principles. Model training and inferencing. Many AI systems rely on predictive models that must be trained using sample data. The training process analyzes the data and determines relationships between the features in the data values that will generally be present in new observations, and the label, the value that the model is being trained to predict. After the model has been trained, you can submit new data that includes known feature values and have the model predict the most likely label. Using the model to make predictions is referred to as inferencing. Many of the services and frameworks that software engineers can use to build AI-enabled solutions require a development process that involves training a model from existing data before it can be used to inference new values in an application. Probability and confidence scores. A well-trained machine learning model can be accurate, but no predictive model is infallible. The predictions made by machine learning models are based on probability, and while software engineers don't require a deep mathematical understanding of probability theory, it's important to understand that predictions reflect statistical likelihood, not absolute truth. In most cases, predictions have an associated confidence score that reflects the probability on which the prediction is being made. Software developers should make use of confidence score values to evaluate predictions and apply appropriate thresholds to optimize application reliability and mitigate the risk of predictions that may be made based on marginal probabilities, responsible AI, and ethics. It's important for software engineers to consider the impact of their software on users and society in general, including ethical considerations about its use. When the application is imbued with artificial intelligence, These considerations are particularly important due to the nature of how AI systems work and inform decisions, often based on probabilistic models, which are in turn dependent on the data with which they were trained. The human-like nature of AI solutions is a significant benefit in making applications user-friendly, but it can also lead users to place a great deal of trust in the application's ability to make correct decisions. The potential for harm to individuals or groups through incorrect predictions or misuse of AI capabilities is a major concern, and software engineers building AI-enabled solutions should apply due consideration to mitigate risks and ensure fairness, reliability, and adequate protection from harm or discrimination. Microsoft Azure provides the Azure Machine Learning Service, a cloud-based platform for running experiments at scale to train predictive models from data and publish the trained models as services. Data scientists can use Azure Machine Learning throughout the entire machine learning lifecycle to ingest and prepare data, run experiments to explore data and train predictive models, deploy and manage trained models as web services. Azure Machine Learning provides the following features and capabilities. Automated machine learning for non-experts to quickly create an effective machine learning model from data. Azure Machine Learning Designer, a graphical interface enabling no-code development of machine learning solutions. Data and compute management, a cloud-based data storage and compute resources that professional data scientists can use to run data experiment code at scale. Data scientists, software engineers, and IT operations professionals can define pipelines to orchestrate model training, deployment, and management tasks. Azure Cognitive Services are cloud-based services that encapsulate AI capabilities. Rather than a single product, you should think of Azure Cognitive Services as a set of individual services that you can use as building blocks to compose sophisticated, intelligent applications. Cognitive services offer a wide range of pre-built AI capabilities across 4 main categories: language, speech, vision, and decision. You can use cognitive services to build your own AI solutions, and they also underpin Azure Applied AI services that provide out-of-the-box solutions for common AI scenarios. Applied AI services include Azure Form Recognizer, an optical character recognition (OCR) solution that can extract semantic meaning from forms such as invoices, receipts, and others. Azure Metrics Advisor, a service built on the Anomaly Detector cognitive service that simplifies real-time monitoring and response to critical metrics. Azure Video Analyzer for media, a comprehensive video analyst solution built on the Video Indexer cognitive service. Azure Immersive Reader, a reading solution that supports people of all ages and abilities. Azure Bot Service, a cloud service for delivering conversational AI solutions, or bots. Azure Cognitive Search, a cloud-scale search solution that uses cognitive services to extract insights from data and documents. Bots are AI-powered software agents that can engage in conversational interactions. For example, a website may include a chatbot interface in which users can submit questions using natural language and receive conversational responses, or an organization might use a bot to answer incoming phone calls and gather initial information before forwarding the call to the appropriate operator. The Azure Bot Service is an applied AI service for developing and delivering bot solutions that support conversational interactions across multiple channels such as web chat, email, Microsoft Teams, and others. AI engineers can develop bots by writing code using the classes available in the Bot Framework SDK. Alternatively, you can use the Bot Framework Composer to develop complex bots using a visual design interface. Searching for information is a common requirement in many applications, from dedicated search engine websites to mobile apps that can find context-appropriate information based on where you are and what you want to accomplish. Azure Cognitive Search is an applied AI service that enables you to ingest and index data from various sources and search the index to find, filter, and sort information extracted from the source data. In addition to basic text-based indexing, Azure Cognitive Search enables you to define an enrichment pipeline that uses AI skills to enhance the index, with insights derived from the source data, for example, by using computer vision and natural language processing capabilities to generate descriptions of images, extract text from scanned documents, and determine key phrases in large documents that encapsulate their key points. Not only does this AI enrichment produce a more useful search experience, the insights extracted by your enrichment pipeline can be persisted in a knowledge store for further analysis or integration into a data pipeline for a business intelligence solution. In this module, you learned what is artificial intelligence and its terms, understood capabilities of Azure AI-related services. This was Cloud Stories Podcast. All related materials you can find in the description. If you enjoyed this module, please leave a like, subscribe to the channel, and share the video. Thanks for listening and have a nice day.